Hello everyone, so here now we are with arithmetic mean, geometric mean and harmonic mean inequalities. So what this says is, if I have a set of numbers, let's take two numbers a and b which are positive numbers, okay. If they are positive numbers, negative numbers will not work. So the positive numbers, the arithmetic mean a plus b upon 2 is greater than or equal to the geometric mean, which is root over ab, is greater than or equal to the harmonic mean, that is twice of ab divided by the sum. Okay. So this is the arithmetic mean, this is the geometric mean, this is the harmonic mean. So just to explain, arithmetic mean is just the average, so you just add them and divide by 2. For geometric mean is basically the square root of the product of those two. Harmonic mean, how we calculate harmonic mean is, to calculate harmonic mean, the steps are, you take the reciprocal of the arithmetic mean of the reciprocals. So what does that mean? If I have the numbers a and b, you take the arithmetic mean of the reciprocals. So you first do 1 by a plus 1 by b divided by 2. So that comes out to a plus b by 2ab. Now take reciprocal of this. So put a minus 1 power and you will get twice ab by a plus b. So that's what the harmonic mean is. Now if I have three numbers a, b, c, so then in the same way we will continue a plus b plus c by 3. This time it will be the cube root of abc, and instead of generalizing the form here, we are just going to write it like this, 1 over a plus 1 over b plus 1 over c by 3 whole to the power minus 1, and this continues. The more important ones are these two, okay, the arithmetic and the geometric mean cases. So let's take a look at this question. So we have got a, b, c, d which are positive numbers. They have been given that a plus 2b plus 3c plus 4d is 12. You have to find out what is the maximum you can make of ab squared cd squared. Okay. So how do you do that? We will use the AMGM property. So the arithmetic mean of, now first look at this. What do we need? We need a with b, another b, c, d and d. Okay. So we need to ensure that we get these terms at least. Okay. Now here we have a plus 2b as one term, 3c as one term, 4d as one term. So we need to split. What do you do that? We rewrite this as a plus b plus b plus, we just need one c, so we don't break that c, but we need two d's, so we break that 4d as 2d and 2d. So now we have got 1, 2, 3, 4, 5, 6 terms. So now we use the AMGM inequality. So a plus b plus b plus 3c plus 2d plus 2d divided by 6 is greater than or equal to the sixth root of a times b times b times 3c times 2d times 2d. Right? This sum we know is 12. So 12 by 6 is 2. So we have 2. And this is the sixth root. So we take 2 to the power of 6 on both sides. So 2 to the power 6 is greater than or equal to. This side now we have a times b squared times c times d squared multiplied with 3 2s are 6, 2s are 12. That's what we have. Okay. So over here, if I now calculate a b squared times c d squared is less than or equal to 64 by 12. 64 by 12 is 16 by 3. Okay. Let's just quickly go through this once. So a, 2b, 3c and 4d we had. We split it as a, b and b because I need b squared. I kept the c as it is. And I split 2d and 2d because I need d square as well. This is 12. We have 1, 2, 3, 4, 5, 6. So 6 terms. The sum of those 6 is 12. So the arithmetic mean is 12 by 6 is greater than or equal to the sixth root of the product of each of these. So a, b, b, 3c, 2d and 2d. Now this is 12 by 6 is 2, we raise to the power of 6, 2 to the power 6, greater than or equal to AB square, CE, D square, and 2 2s are 4, 3s are 12 is coming extra. So we divide by 12 and get this. So this is the answer to this question. Let's take a look at this one. So a plus b is 9, we have to find the maximum value of this. A minus 1 squared times b plus 2 cube. Now first of all, we don't have a minus 1 b plus 2, so we need to first ensure that we have that. So a minus 1 plus b plus 2 would basically be a plus b minus 1 plus 2. So it's a plus b plus 1, so that is 10. So that's the first step. So we know that a minus 1 and b plus 2 adds up to 10. But I need two such a minus 1. So what do? I do a minus 1 by 2 plus a minus 1 by 2. I need 3b plus 2. So I do b plus 2 over 3, b plus 2 over 3, b plus 2 over 3, and this is 10. Now using the AMGM inequality again, the sum of all of these, so a minus 1 by 2 plus a minus 1 by 2 plus b plus 2 by 3, b plus 2 by 3, b plus 2 by 3 divided by 5 is greater than or equal to the fifth root of the product of all of these, which will be a minus 1 squared times b plus 2 cube divided by 4 and 27, that is 108. That's what I will get, because when I multiply this, 27 and 4 will come, 27 4s are 108. Now this is 10 by 5 is 2. We have to take the fifth power on both sides. So 2 to the power 5 on this side. Okay. So that means we are having the answer as a minus 1 squared times b plus 2 cube is less than or equal to 108 times 32. Whatever this result is the answer that we have. I hope this is clear now. The next question and the last one in this, you have to find the minimum value of this expression. So how do you find the minimum value of this? So it is x cube plus x plus 2 whole divided by x. So we split. This is x squared, that's 1, and that's 2 by x. Now what do I do with this is just do a little thing. This 2 by x I split as 1 by x plus 1 by x and keep the 1 outside. Now what about this part? This is a constant, so you don't need to bother about that. So what about this part? If I use the AMGM thing again, observe x squared plus 1 over x plus 1 over x by 3 is greater than or equal to x squared times 1 by x times 1 by x cube root. So this now becomes x squared plus 1 by x plus 1 by x by 3 is greater than or equal to 1, because this cancels out completely. This by itself becomes 1. So that means this value is greater than or equal to 3. So this is greater than or equal to 3 plus 1, that means greater than or equal to 4. So the minimum value of this is 4. So I hope these examples were clear. Thanks for watching.